to stay here, to be invited to do this speech. And our laboratory works in endocrinology, experimental endocrinology, and we developed some techniques, and this work is exclusive Brazilians. We work with testes, and Sertoli cells, as well, is well known. Sertoli cells is responsible to the spermatogenesis, the development of the germ cells, and Leydig cells to provide the androgenic production. And these cells in adults, male adults, the Sertoli cells provides the physical and nutritional support to develop in germ cells. It's very important to the different phases of the development, and divides also the seminiferous epithelium in two compartments, the basal compartment and the adluminal compartment, to provide a special environment to germ cells. And these cells, also called nerve cells, produces glucose metabolites to sustain spermatogenic processes, such as lactate and pyruvate. Our focus is immature cells, immature testes, because the number of Sertoli cells reflect in quantity and quality of spermatozoa produced in normal adult. Proliferation and maturation processes occurs until puberty. These cells proliferate during the childhood. In the proliferative period varies, depends on the species. But in humans, after birth, we have two different periods. Neonatal proliferation that increased in Sertoli cell number, and before puberty, pre-puberty period, when we have another proliferation period here. In rats, both periods are overlapped, and until 15 days after birth, these cells are in the final number until adulthood. Failure in proliferation Sertoli cells is involved in several pathophysiological processes that lead to reduction in semen quality and number. Immature testes is the focus of our study, and at day 5 in rats, these cells, the Sertoli cells, perform all structure in the seminiferous cord in this age. And these cells, immature cells, differ extensively from adult cells in any different ways. Until day 15, the germ cells in beginning are inside in the side adluminal of the tubule, and until day 15, when finish the proliferation of Sertoli cells, the germ cells migrate to basal side. These processes depends on hormonal and paracrine and autocrine regulation, intensive. The main hormone that regulates this process is the hormones related with hypothalamus pituitary gonad axis. And FSH is the main hormone that stimulates the growth and proliferation of Sertoli cells in this period here. LH also is important because, of course, LH stimulates testosterone, and testosterone, besides it is low level at the beginning, at the prepubertal animals, it is important to the proliferation because without its receptor, we don't have normal testes. So, also follicular FSH stimulates the increase of IGF-I to complete the proliferation function in this period. And of course, androgens and estrogens, because in this period, Sertoli cells express lots of aromatase, that increase estrogens in this period too. Of course, we have other growth factors acting in the cells, inflammatory cytokines, thyroid hormones, and vitamins A and D acting in these cells in this period. To also, among others, of course, to also these hormones, it is described its receptors, and it is known that they act in the cells. They are important to act in the cells. But what we have to do is study with more each case, each hormone, what is doing in these cells, because some of these hormones, it is known that they are important, but it isn't know exactly its way of action in the cells. We were focusing insulin and IGF-I, where it is known that insulin is important in this period because there are some cases in diabetes type 1 and type 2, mellitus type 1 and type 2, that it is described male infertility or subfertility or compromise the quality of the sperm. And also, in this case, DM could cause alteration in the levels of the hormones, such as testosterone, LH, and FSH. There is some studies showing that insulin is indispensable to prenatal Sertoli cell proliferation, and a few studies really were related in postnatal, the phase that we studied. In this study, Pittetti showed that in animals, in rats, with lack of insulin receptor and IGF-I receptor, there is a decrease in the size of testes, and these normal testes without this decrease, this lack only in Sertoli cells, the lack of Sertoli cells only, the lack of receptors only in Sertoli cells. Insulin receptor, when lacking, decrease slightly the size of testes, but IGF-I and both IGF-I receptor and insulin receptor decrease strongly decrease the size of testes. So our aim is to investigate the effects of insulin and IGF-I on some parameters that we study, such as calcium, amino acid, glucose uptake in these immature testes. And we study also electrophysiological effects of these hormones in membrane of these cells. We also investigate the pathway involved in the action mechanism of action of these hormones or factor. To do this, we use the electrophysiological technique and amino acid and glucose transport using radiolabeled amino acid and glucose. In the electrophysiology study, we used the standard single microelectrode recording. That is a technique where we use entire whole seminiferous tubules. You use one testis here, and we stretch this test and isolate some few seminiferous tubules to, after that, impale and register the membrane potential. We apply in this chamber that have open flow every time. This chamber has 1 ml of volume, and the flow is open every time. When we apply the hormone, also it is open. The tip of the micropipette, we apply the hormones and register the membrane potential alteration after this apply. Here, in this study, we review this technique. And here in the microscope, we monitor the impalement. And this intracellular register shows us that Sertoli cell has a steady membrane potential. And this is a good thing because the average of membrane potential is approximately minus 45 millivolts. And this is a good because this stability, with this, we can apply the hormones, and if these hormones change any current in ionic channels here, we will register. Another method, it is an assay with radiolabeled compounds, such as 45 calcium and amino acid and glucose, each one with different times of incubation. As results, we observed that insulin and IGF-I produces depolarizing effect on membrane potential in mature cells. And this depolarization occurs, and it is significant at 180 seconds. And it occurs when we apply insulin and IGF-I. This effect was observed mainly in 15-day-old rats, and 30-day-old rats, it is very reduced, this effect, to insulin and to IGF-I also. So we apply in the superfusion chamber, we added JB1, that is analog to IGF-I, and it binds in its receptor and blocks this receptor. So we observed that both insulin and IGF-I have this effect on membrane, blocked in the presence of GB1. We also show that calcium is involved in membrane action of both insulin and IGF-I, because we, again, with the superfusion, we apply verapamil, and it blocked both insulin and IGF-1 response. After that, we studied the uptake of calcium using red-labeled calcium, or isotopus calcium, sorry, 45 calcium. And we observed that at 2 minutes of incubation, we used tests from 12-day-old rats. Insulin can increase the calcium uptake, and IGF-1 also. This effect was blocked in both cases by JB1, that analogous of IGF-1 that blocks specifically IGF-1 receptor. Also, insulin and IGF-1 increase glucose transport in the cells, and it was also blocked in the presence of GB1. We investigate the effect of wortmannin. It is a PI3K inhibitor. And in all experiments, calcium uptake, amino acid uptake, that insulin and IGF-1 increases also, and glucose uptake, wortmannin blocked their effects. In conclusion, we will show a schematic, a schematic representation here, showing that the IGF-1 receptor may be involved in these actions of insulin and IGF-1 through PI3K mechanisms that increase or stimulates AKT to increase through calcium channel subunits, regulatory subunits, and it also increases glucose transport and amino acid transport. What's the physiological importance of this? Because this could be the mechanism, besides other mechanisms already described, that insulin and IGF-1 can help FSH, the main regulatory factor in proliferation cells, Sertoli cells, and it is can be a mechanism through the proliferation is stimulated by insulin and IGF-1 in this age in the cells. All these results are published here, one in Frontiers here, 2013, and here. This article is a review of another that our group did related to these actions and another hormone actions in the cells during this period. And if you want to know more about it, we have a page in the internet here, if you know. And all these results are the PhD research of my student here, Gustavo. And here is my group and other researchers involved in this work. Thank you a lot.